All right, this is for the example. This is an example of project part one, um, which is due on the 20th, which is Friday, of course. All right, so I just wanted to do this. All right, so let's say you have three different planets. This is planet A for me. Okay, so I'm just going to use this as my example. There's some other information there that's going to be for the other projects. Okay, so what the mass is compared to Jupiter, or what the mass is compared to the Earth. We'll get into that more in the next project. Okay, so for right now, all we're doing is we're going to calculate the period of this planet around a star. Now these stars that we're using here, we're going to pretend basically, because I actually used this. This is actual data from the tests and the Kepler missions, which you know found a lot of exoplanets around other stars. Anyhow, what we're going to do is we're going to just use we're going to imagine that these stars are the exact same mass as our sun. And the reason that we do that is, of course, we get to use this formula right here. P squared, which is the period squared, is equal to the average distance the planet is from its star cubed. This is of course also known as Kepler's third law. All right, so we'll talk more about that as the as the week progresses. All right, so in this particular thing, in this particular Kepler's third law, the way this works is the period is in years, and the average distance A is in units called astronomical units, AU. And you can see from my planet, my planet A, um, the the average distance between the planet and the star is 3.4 astronomical units. Okay, so that's out beyond the orbit of Mars, for example, if we were talking about our solar system. But of course, we're talking about an exoplanet, a planet that's around another star. All right, so let's just go ahead and do this. All right, so you just have to rearrange this. Now, by the way, I'm using my finger, so sometimes this might not come out very well. I left my stylus in my office, so I'll do the best I can. All right, so to take this equation right here, and why is that not? Let's see. So that this equation right here, and to use this to solve for the period. Okay, so of course I'm going to rearrange it. The period. This is just a little bit of algebra. Since it's p squared, I have to take the square root of both sides. So this is going to be the square root of a cubed. All right. So this is fairly easy, and so now I'm going to put the numbers in, and the number that I'm going to use. So you use, of course, if there's a here. Let me see if I can show you what I'm talking about. There is a um, here it is right here. Okay, this is at least part of it. There are your names. Okay, so like there's the mass of your planet A, the radius of your planet A, and this is the column that you're interested in, the distance, right, of your planet is, and then of course there's the ones for planet B. I know I didn't get very inventive with the names. There's the distance planet B is. So you look here. Let's go back. So you would find your name. Let's say I'm just. It can be anybody's name, of course. And then what you're going to do is you just go across. Okay, so like for this person here, actually, let me use one that's not. Anyhow, it doesn't really matter. All right, so for this person, what you would do is their distance A would be 0.057. The distance B, let me scoot it over so you guys can see this. Their distance B would be um, 1.08. I'm sorry, I looked at the wrong thing. Their distance B would be 3.23. And then, I don't know why I can't scoot that over a little bit. There it is. Okay. And then their distance C would be 0.058. Okay. So that's all you do. Just you go over here, you find your name, and I just use the list that I have on Blackboard, and that's basically where you're going to get your 3. So remember, we're only interested in the distance A from the star, the distance B from the star, and the distance C from the star for project A. These other things, the mass and the radius of these worlds, we'll get into in future projects. All right. So let me go back to this. All right. And so what we're going to do here. All right. So I just wrote the numbers in here. So this is the square root of 3.4, right? So I get the 3.4 from right here. This is my little example. 3.4 astronomical units. But remember, you have to cube that. Okay, so you have to cube the 3.4. All right. So the answer will come out in years. Okay. So this will be some number. It'll be some number of years. All right, and then we'll convert it to days in just a moment. Yeah. So let's see. Where's my calculator? I had it out a moment ago. No, that's not it. All right. So this is just a calculator from my. I just want to go through this real quick with you. All right. So 3.4. All right, and so you have to raise that to the to the third power. Okay, so that for this particular calculator, that's the X to the Y button. All right, and so it gives you a little caret right there, and so that's cubed. All right, so this is going to be 3.4 cubed if I hit equals. All right, so there it is. But of course, remember, I have to take the square root of that number. Right, so if I do that, then I just hit this square root button. Right, and there it is, right? So that's the square root of 39.304. All right, so that's the answer in years. All right, so here, let me move this. So let's say if I wanted to round this to 2 places past the decimal. All right, understand what I'm talking. So 2 places past the decimal, that would be 6.27, right? Because what's beyond the 6 here is 5 or greater. Of course, it's a 9, so you round up, right? And so the answer would be here. So it would be 6. Here, let's see. Let me 6 here. 6 point. Jeez, I got to use the mouse, unfortunately. Okay, so. That's an awful looking. That's supposed to be a decimal. All right, 6.2. Sorry, I'll get my stylus. It's in my office. Anyhow, so 6.2, and so you wouldn't you would round it to a 6.27. All right, so there's, and of course it's years. All right, so that's 6.27 if we rounded to 2 places past the decimal point. If it was rounded to 1 place past the decimal point, it would be 6.3. All right, so all right, let's convert that to so we're gonna use this number, and we're gonna use the fact that well, here I'll let me pause it, and then we'll get a fresh thing. All right. All right, so let's finish this one. So this is the only conversion that we really need, is that 1 year is 365.25 days. That's actually that's approximately true. That's not actually astronomically correct, but we'll go ahead and use that anyway. All right, so anytime you do a conversion, what you do is you use the conversion factor. All right, so here, let me draw this. And what you're doing is you want to cancel, so we need to cancel a year. So I'm going to use 1 year, right? That's going to go in the denominator, and then the other side of the equation, the conversion, goes in the numerator. So this is 365. I'm using the mouse, that's why it's a little difficult to write. That's a decimal point. 0.25. All right, so 2.25. All right, and then all right. So notice the year cancels, and so you're just multiplying 6.27 times 365.25, which I've already done. Here, let me bring the calculator over so you can see that. All right, so this is the answer. So it would be 2,290. And so let's just because we rounded two places past the decimal, let's round two places past the decimal again. So this would be 2,290.12. All right. So here, So that's it. Okay. So there's our example. So you're just doing that for your three planets. You figure it out. How many years it is and how many days it is. All right. So I'll do examples for the other projects in. Let me write this out. All right. So this is equal to. Again, it's a pain to write this stuff out with the mouse, but I will try. All right, so it's 2,000. 2,200. What was it again? 2,290. 90. That's a 0. And then there's a decimal. The decimals don't really look very good here. 0.12. Right? Is that right? What was? Yes, 0.12. So it's 117, but since 7 is greater than 5, we round up. All right, and so that's the number of days. A D for days is perfectly fine. So there's the answer for figuring out what the period is in days, and this, of course, is the answer for the period in years. All right, so that's how you do that one. And project part A is project part 1 is very simple. So again, you just use your three planets. Just look at this. So you just look at this thing, and then you find whatever your name is. You just look and you find the distance for your planet A, the distance for your planet B, and then the distance for your planet C. Okay, so let me scroll over just a little bit more. There's the distance for planet C. All right, and that's how you do this.